Hello and welcome to another video, and in this video we're going to be talking about heme degradation. So how hemoglobin is broken down in the body. So there's really two separate pathways, at least that's how I like to think about it. I think it makes it easier to understand. So the first starts with just a red blood cell and globin. So if you remember from our previous anemia videos, we know that hemoglobin is made up of heme and globin, and then heme is further broken up into iron and protoporphyrin. So in this first pathway up here, we're talking about globin, and that is going to be broken down into amino acids that can then be recycled to form different types of proteins and all sorts of things in the body. And that happens when these red blood cells are broken down by macrophages. Once that happens, we get our iron 2 plus and something called biliverdin. And then our iron gets turned into iron 3 plus, which is carried by transferrin, which we learned in previous videos as well, acts as the transport molecule for iron, and then that gets put into storage in the liver in the form of ferritin, which we also learned previously is our preferred method of storage in macrophages of the bone marrow and the liver for iron. And if that ever overflows, then we switch to hemosiderin, which is another storage form. So hemosiderin is the other storage form of ferritin, or not other storage form of ferritin, but hemosiderin is another storage form for iron other than ferritin. Hepcidin is actually a hormone that lets the body know we have enough iron. So you can think of it as, if we have ferritin, a lot of ferritin or a lot of hemosiderin, our hepcidin should be activated or elevated in the body, letting our body know, hey, we have enough iron, don't absorb as much of it, etc. And then in the other pathway, we have heme. Heme is going to be broken down again into biliverdin, like we saw over here. And biliverdin is going to turn into bilirubin through an enzyme called biliverdin reductase. And bilirubin is going to come together with albumin, and together they're going to travel in the bloodstream to our liver, and bilirubin is going to be conjugated into something called bilirubin DIG by this enzyme. And bilirubin DIG will make its way to our intestines, and there it'll be unconjugated by the good bacteria you have in your gut, and that will be converted into something called urobilinogen, which is actually colorless. And then that eventually will exit the body either via urine or feces, and it'll be converted, if it's via the urine, into urobilin, which is going to give urine that dark yellow color, and sterosibilin, I think I pronounced that right, which is what gives your poop that brown color.